Hi everyone and welcome back to the multiverse of 100 plus data science project series. In this video, we're going to discuss about the stock trend predictions using Python and machine learning. In the screen, you can see here one application that's called the stock trend predictions. And if I go down, you can see here some kind of plot, just like the exponential moving averages, as well as the predictions and the original trend, and as well as the descriptive analysis of your data. And also you can see here one button where you can download the dataset from here. So in this one, you're going to making this full application from the scratch using Python and Flask as well as the machine learning. So without wasting your time, I'm going to start the tutorial right now. Well, so now it's time to creating here our stock price predictions model, and also we're going to do the coding part in the Jupyter notebooks. So let's importing here the pandas, numpy, matplotlib, and the pandas data reader. So let's import pandas as pd. Then I'm going to importing here the numpy as np. Then also I'm going to importing here the matplotlib. So matplotlib.pyplot as plt, and as well as I'm going to importing here the pandas data reader. So let's say import pandas underscore data reader as data. As well as I'm going to giving here some style. So let's say plt.style.use. Let's call 5, okay, 30, 38, okay, 538. This is nothing but one style for the matplotlib graph, and I'm going to giving here the matplotlib inline so that it will show in the inline format. So let's say inline, shift enter. You can also using here another style called the ggplot, okay, ggplot. So 538 is another kind of style in the matplotlib, right? Now we need to download the data set, right? So in order to download the data set, what I'm going to do, we can using here the Yahoo Finance, okay. Inside the Yahoo Finance, we have all our stock data. So if you go on that, this is the website for that. If I click on that Yahoo Finance, and inside that you can search your company. So if I search here, let's say Apple, okay, and you can see here we have the Apple, and you can see here one equity name AAPL. If you're using this AAPL, this Apple data should be downloaded. And if I using here another company which is from the India, that's called Power Grid, okay, you can see Power Grid NS, Power Grid Corporation of India Limited. So I'm going to using this one Power Grid.ns, and you can see this the equity name. And based on the equity name, so what I can do is simply going to download data set from this Yahoo Finance. Okay, so this is nothing but on a stock market application. So you can just go on here, and okay, so let's go on the code. Okay, okay, here our code. So what I can do, we're simply going to import here one library that's called the Y Finance. Okay, using Y Finance, you can actually download the data set from the Yahoo Finance website like that. So let's import Y Finance, okay, as YF, okay. And after that, you need to giving here one stock name. So let's say stock equal to Power Grid.ns, okay. That's my stock name, okay. And after that, what I can do, we need to download it. Let's say yf.download, and inside this download, you need to giving here your stock name and also your start date and the end date. But our start date and the end date is not defined here. So what I can do, we can import here the date time. So let's say date time, date time as dt, okay. So you need to giving here on a start date and as well as the end date. So what I can do, you can create a variable called a start, and we can giving here the date of today. So let's say date time, okay, date time. So start date is nothing but where you're going to start it, and end date is nothing but the today date. So let's giving here one and variable, and let's say dt dot date time, okay, and let's say giving here today date. So let's say 2024, and let's giving here the November. So you can start from 1. So today is nothing with the 14 November. So let's start from 1, okay. I mean 1 November 2024. Okay. So, and date time is nothing but let's say giving here the 2000s, and let's see how many data are available for the Power Grid. And let's say 111. Okay. January 1, 2000s. And end date is nothing but dt dot date time is nothing but today date is nothing but 14. You can also give it here 14, but I just give it here 1 because I'm going to start it from the first, okay, first week, first day of the November. Okay. So now we have our data. So let's store into a variable called df. Okay, you can also make it data whatever you can. Okay, and now shift enter. Now you can see just to white, it will download this data set from the Yahoo Finance website. And now you can see here 100%, one of one completed. You can also check in this the data. So let's say data.head. Okay, you can check in this one, and your data is not okay. It should be the df.head. So df.head, and you can see here this is your data. Okay, it's your data. You can also see the tail of that, so that you can see that the last date of that last date is nothing but 2024 10 month 31. Okay, it's nothing but the data of the October's. Okay, the last is nothing but from the one. Okay, and you can also check in that if I using here the df.head, then you can see here the date is started from 2007. That's when before that PowerGate don't have any data in the Yahoo Finance website. Okay, now what I can do, we can simply going to check in the data set shape. Okay, so you can see the how the shape look like. This is the shape of your data set. Okay, and also you can check the information regarding your data set. So let's say data.info. Then you can see here this is the information regarding your data set. So you can see here at just close, then close below, high, low, open, and the volume. Okay, and you always see that you don't have any null value. You can also check in this out. Let's say df dot isNail. Okay, you can saw isNail dot sum. Then you can see here it won't have any missing value at all. You can also describe it data set. So let's say describe. Okay, for seeing the descriptive analysis of your data. That's just like the count, mean, standard deviations, minimum, and the 25% percentile, 50% percentile, 75% percentile, and the maximum value of that. Okay, so see how it actually look like. So now you can also reset your index because the index is not in the correct positions. So what you can do, you can simply going to say that let's say df equal to df dot reset, okay, index. Okay, you can reset the index, and now if you're checking this out, that's a df dot shape, then you can see here shape is increases by 1. And if you're checking this df dot head, then you can see just a white, you can see it is creating here an extra column called date. Okay, extra column called date. And if you wanted to check in this date df dot columns, okay, columns, then you can see it have a date as just close and the high, low, open, and the volume. Okay, and also having the power grid dot ns. This is nothing but my company name. Cool. Now what I can do is simply going to creating here one candlestick plot. So candlestick. So candlestick. If you know about this, if you know about actually stock price deeply, you know about the candlestick. What is actually candlestick? So let's go on the Google and search for that. Okay, just to avoid. Okay, so let's search the candlestick in stock. And you can see candlestick is a type of price chart used in the technical analysis, basically in the stock price. And if I go on the image section, so let's open one image. So let's open the first image, and then you can see we have two types of actually boxes. One is nothing but the green boxes, which one is nothing but called the increasing the stock prices, and the red is nothing but called the decreasing of the prices. It's nothing but based on your open and the close prices. And you can see high to low, high to low, and this is for the high sections. This is the close one, and this is the open one. That's in for the high sections. For the green signal, your open should be low and your close should be higher. And for the red boxes, your open should be the lower and close should be the lower. No, okay, no, not sorry. Actually, for the decreasing, open should be higher and close should be the lower. Okay, this is called the candlestick. Okay, you can also see this kind of graph in your Binance applications, just like trading application. You can see this kind of graph as well. Well, so now let's try to plotting here our candlestick. So for that, you're using the plotly. So let's import plotly dot. It should be the graph object. So let's say graph objects as go. And after that, what I can do is simply going to creating here one figure. So let's say figure is nothing but one variable. Let's say figure equal to go dot figure, and inside the figure, what I can do, we are going to using the data as a candlestick. Let's say go dot candle. Okay, candle candlestick. Okay, candlestick. And inside that, for the x-axis, we're going to giving here our data. So our data is nothing but our df, and from our df we can giving here the date. Based on the date, we are going to plotting our candlestick. And now inside your candlestick, you need to giving here the four value. Is first one is called the open value, then high value, low value, and the close value, right? That you can see in the pictures when I search on Google, right? So what I can do, we simply going to giving here first open value. So open value is nothing but coming from df of open, because we have it out. You can see we have the open. Then after that, what I can do, we need to giving here the high value as well. Okay, so let's giving here the high is nothing but our df of, then what I have, we have the high. And after that, okay, not high actually, it should be the high. And for the low value, we have the df of, it's called the low. And after that, we're giving here our close value. So let's say close equal df of close. Cool. And finally, we need to also show the figure. So let's say figure dot show. And before that, you have to give the title level so that it's look bigger, and you can also do the analysis on that. So let's say figure dot update. Okay, so let's say update layout, and inside that you can giving here our x-axis. Okay, x-axis is the range slider visible. Okay, equal to false. So if you actually uncomment these lines, if I uncomment this line, you can see one slider. Just to wait, it will load in this one. Okay, you can see one slider, and also one more thing, that your graph is not visible here. Why this kind of problem actually happening here, I also told you. Because most of the people actually are building this kind of candlestick, and when they download the data set from the Yahoo Finance in this kind of way, they're actually unable to printing or show the candlestick chart. So you can see this axis is range slider is right now invisible. Okay, we just make it invisible and try to make it false. So why it's unable to creating here the candlestick chart? Why? Because see the df, if I see the df, it having one column, with this column it having the another column, that's mean it having multiple number of index, it having the multiple number of index. So if we want to save this data in a form of csv, we can simply going to creating this candlestick. We can simply go into candlestick, creating the candlestick, because in our data it having multiple number of index. If I'm going to checking this close, high, low, okay, how can you start the data from here? We can using here one technique, we can simply going to save this data set from the csv, and after that we can load it separately and try to plot here our candlestick. Okay, so let's try to checking this out, that is really working or not. So let's say df.toShape to csv, to csv, and inside let's give it here the name, let's say power grid.csv, and that's our data. So let's say data, let's 01 like that. And now our data is saved, and if I'm trying to show this out, let's say data 01. Okay, I need to also load it out, right? So let's say data 01 equal to pd dot read underscore csv, and inside that I can give in here power grid dot csv. Okay, power grid dot csv. You don't need to giving here this variable name as well here, because it's not necessary when you are going to saving your csv file, right? So if I wanted to see this out, so let's say let's running this out, and if I'm checking this data 01 dot head, and then you can see one data frame as well. Okay, data frame here, and if I give it here the data on here, so let's say data 01, and if I copy this one, paste here, paste here, paste here, paste here, and shift enter, and you can see boom, one candlestick graph, you can see here. Okay, if I zoom in, and then you can see here it having one green boxes and one red boxes. And if you see the green box, if I hover over here, you can see open is nothing but 111.8813, and close is nothing but 113.5125. That's mean the candlestick starts inside the candlestick starts as a candlestick graph. We can see that the green signal is nothing but for the increasing value, and the red signal, the red boxes, is nothing but for the decreasing one. Okay, if I hover over here, you can see open is nothing but 113.9625, and close is 112.1625. That's mean it is decreasing. Okay, This is how you can actually show the trend. You can show your stock prices, it is increasing or not, based on your open and the close below. So now what I can do, I is simply going to remove the some of the column which is not necessary. We can simply go to remove them. Just like the date and the add dz close is not important for me. So what I can do, you can using as a df, not data one, right? So what I can do, we simply going to remove it. So let's say df equal to df dot drop, and inside that we can giving here our date and as well as our add dz. Let's say add dz close, because it's not necessary, you can simply going to drop it out. So let's say x is equal to 1. Okay, so if I want to check in this out right now, df dot head, then you can see how our data set look like. We have the close, high, low, open, and a volume. Okay, now what I can do, we simply going to creating one plot so that we can checking the closing price over time. We can checking the closing price over time. So you're already importing the matplotlib, right? So let's creating here on figure. So let's say figure, and inside that I'm giving here my fig size. So let's say fig size, and inside that I'm giving here my size of that. Let's say 12 comma 6, and we're simply going to creating on float. So let's say plt.float, and inside the float we can giving here our data dot close. And this is a new technique, data dot close. Otherwise you can giving like that, data of close, right? And inside that you're giving here a level. So let's giving here a level in the form of f string. So let's f string, and inside that you need to giving here our stock. Okay, let's stop. Let's say if I am sometime, okay, or any other time, if I try to actually changing this name of your stock, it can be Apple, it can be Google, because I'm working on the Power Grid right now. When you changing these ones, when you changing this name, let's say I'm going to changing here this APPL, okay, sorry, APL, Apple, okay, because this is the equity name for that in the Yahoo Finance website. If I change in this name in the variable sections, inside that it will automatically changes. Inside that it will automatically changes. So that's why I'm actually giving here one f string. So it should be our closing price. So let's say okay, closing price. Okay, that's our closing price. And inside that what I can do is simply going to giving here one line width. Let's say giving a line width, let's say 2. You can give it whatever you want. And after that you're giving your title. So let's say plt dot title, title, and inside that what I can do, we can giving here same f string, and inside that we can giving here on a stock. Okay, let's say closing price over time. So let's say closing price over, okay, it should be prices over time. Okay, and it giving here inside one string. Okay, it should be not there. Okay, fine, now it's closed. Now let's give it here on x level. So inside our x level, what I can do, you can giving here the date of that, because based on the date it will try to plotting this out. And plt dot y level, let's say it should be the closing price, let's say USD. Okay, so let's say plt dot legend, okay, and plt dot show. Oh, plt dot show like that. Okay, any error? Okay, it should be not data, it should be the df, sorry. Okay, now you can see here how the data look like. Okay, how the data look like. Okay, you can also decrease the line plot from here. Now you can see how the plot or the power gate.ns closing price over time. You can change from here. You can change, let's say it can be open. You can see the open prices. If you wanted to see the volume, you can see the over the volume price. Okay, how it will increases and decreases. So it's your homework, okay, to do that for the open, for the close, for the volume. Okay, let's try to do that. Okay, so we do it for the which one. Okay, let's remove all of them, and let's try to remove this one because it's not needed at all. So let's making it call close. Okay, now it's look good because we don't need the level one. So open, it should be the opening price. Okay, opening price. Okay, so it should be the opening prices. Opening prices, it's not needed. Okay, so shift enter. Now you can see here, this is the graph for the opening prices over time. Okay, so you do the same thing for the high and the low. So let's try to copy this out. Okay, you can give it here the high. Okay, the high prices. So you can see high and high and high, just like that. And this is the for the high, how the graph look like. And you can do the same thing for the rest of them. Okay, it's your job to do that. Let's try to do it or not. Okay, okay, fine. And let's try to pass it here, and it should be the volume. Okay, volume. So let's say volume. Let's say volume bus. Okay, so this is the graph for the volume. You can also change your line height as well. So if you say that, this is how the line height look like. Okay, I will do that. Okay, fine. But opening, okay, low is actually missed. It's your job to do that. Okay, so now what I can do is simply going to actually uh, uh, using some technique in the stock prices. In the stock prices, there should be two technique. One is called the moving average, and another one is called the exponential moving average. So based on using the moving average, you can predict the next day predictions. Next day stock prediction, you can actually do it use the moving average. Now the question is, what is moving average? So moving average is nothing but called the high and average is moving in a certain manner. Okay, let's take one example. Let's say we have one data. So let's say we have some data. Let's say 20, 30, 40, 50, 60, 70, let's 70, 80, 90. So let's say I am going to calculate the moving average for last 5 days. For the last 5 days, I am going to calculate the moving average for that. That's mean this is the first day, second day, third day, fourth day, fifth day. The moving average for the fifth day, I am going to calculate here. Okay, now you can see if I calculate this moving average for the 20, how can I calculate them? I can calculate them because it don't have any value before them. It's nothing but the problem in the stock in DS. How are you going to actually how are you actually going to actually calculate the next data element? Okay, like that problems. So if I calculate it for the 20, I can calculate them. Okay, it will give me -1 or it will give me the null. So for the 10 it should be the null, for the 20 it should be null, for the 30 it should be null, for 40 it should be the null, because I am going to calculate the for average for the last 5 days. That's mean before the 44 days it should be the null. If I'm trying to calculate it for the fifth number day, how can I calculate it? How can I calculate it? I need to join all of them. I need to add all of them. So add all of them, 13, 14, 15, and I need to divide it with the 5. Then after that, I can getting my moving average value. And based on the moving average value, I can predict our stock price for the next day. For the next day, just only one next day. Okay. So what I can do, let's try to creating here, copy this out, and I'm going to creating here variable called temp data. Let's say temporary data, just for checking, just for the checking purpose. So let's say I'm going to simply going to printing it here. So let's say print sum of temp data. Okay, it should be the method. So it should be the temp data. Okay, temp data. I'm going to take in for 1 to 6. Okay, 1 to 6, and I'm going to divide with the 5. Okay, anything wrong? Okay, invalid syntax. I need to shift enter, and I need to sorry not actually comment out this line. Anything wrong? So list and the having the problems. Okay, I need to keeping here on here. It's having the bracket problems. Okay, and you can see here I got here the 40. I got here the 40. So 40 is nothing but is starting from here. So if I going to start it from 0 to 5, it should be the first 5. So it should be the 13.0. If you want to start it from the here, so you are starting from 1 to 6. That means it should be the 14.0, like that. This is how you can calculate the moving average for the value. If I check this out, let's say 1 to 6, 1 to 6, you can see we got 40. if I calculate them for the 2 to 6, okay, let's say 2 to 7, then you can see here we have got the 15, just like that, 15.0. That's why it's called the moving the average. You can see average bin is moving from here. Okay, so now what I can do, we simply going to see this in the pandas. So let's say import pandas as pd, and I'm going to convert them into the data frame so that I can using here the predefined method are available in the pandas. So let's issue the temp data, our temporary data, and that's our let's say df01 like that. So our df01 is ready or not? So pandas has no attribute called data frame. Okay, it should be data frame, not date frame. Okay, so let's say df01. So that's our data frame is ready, just like this, our temporary list. And now how can you use here the this technique to calculate the moving average for the each of the row? So we can using here a technique that's called rolling. So let's say df1 dot rolling, and inside that you need to rolling for the last 5 days, and after that you need to taking the mean of that, nothing but call the average. Now you can see here first four value is nothing but the nan value. It's nothing but the nan value. You can see nan value. Okay, so when actually rolling it out, you got some nan value. Now we can after that you can see 13, 14, 15 like that you calculate here manually. So this is nothing but the technique for the moving average. Now using this technique, so what I can do is simply going to taking the rolling of the moving average for let's say top 100. Okay, and after that you can rolling for the 200, you can rolling for the 250. Okay, whatever, you can actually taking this out, and you can also taking the percentage of the each of your columns. Okay, so what I can do, let's say I'm going to taking this closing value, rolling for the closing value, because closing value is important here. So let's close dot rolling, and inside I give it to the 100. Okay, and I'm going to take in the mean of that. Okay, so it don't have any closing value, it should be the df, sorry. Okay, so we got here the moving average for the first 100 dash. For the first 100 dash, we got here value inside our moving average ma 100. So this is nothing but a value for that. Some first 100 value is nothing but nan, and after that all the values should be calculated just like the formula that actually using it here. Now our moving average for the 100 is ready right now. So what I can do, we need to do the same thing for the moving average for the 200. Okay, let's do the it for the 200. You can take it 250, 300. It's based on your data. So for my data, it's okay. Okay, so let's try to do the it for the 200. Okay, so my moving average for the 100 and the 200 is ready right now. Now what I can do, I simply going to creating here one graph for that. So what I can do is simply going to copy this out. I'm going to copy this out, and I'm going to paste it here. Okay, so let's take some shell, and now inside this plot, what I can do, I can giving here my moving average value. So let's say ma 100, and after that I can copy this out, and I'm going to paste it here, and it should be the 200. So let's remove this title because it's not needed at all. Okay, now you can see how the moving average is look like. Okay, so let's also printing here the our actual one. So let's copy this out, and the actual is nothing but my df of close. So let's say df of close. Now you can see this our actual, that is nothing but our actual trend. Now based on the trend, you can see here that's our moving average. Now based on the moving average, we can actually predict our prices. We can predict our prices. Okay, it's nothing but, let's say, remove this one. Let's remove this one because it's not necessary at all. Just show the stock. Okay, we can give it here. So this is nothing but called the close price. Okay, it's for moving average. So let's say moving average average 100, and this is nothing but the moving average 200. Cool. Now you can see how they look like. You can see our data, based on our data, actual data, our moving average value is also following this one, but having some problem. You can see having some gap on that, and you can just predicting here the next day data, next day predictions. You can actually calculate it using the moving average. Is it okay? Not, it's not okay. Let's say I'm asking you questions. Let's try to predict the next 30 days stocks. You can't do that using a moving average. You can't do this using the moving average. So for that, LSTM is come into the pictures. LSTM is come into the pictures. So how can you do that? How can you do that is using LSTM? And why LSTM? Why not RNN? How I'm actually building the model, then I'm going to actually discuss about that. Why not RNN? Why LSTM? And why we need to using the LSTM here? Okay, because I need to also explore one more thing that's called exponential moving average. So that's why I stop it here. So what I can do, I am simply going to copy this one, and after that, I can copy it or not. Okay, let's type it out. Okay, so let's say df dot close, and inside that I'm using here EWM. Using this EWM method, you can calculate the exponential moving average. Okay, you can see this is nothing but the normal moving average. Now let's see if it is possible to actually creating here, if it's possible to actually solve the problem using the exponential. Let's try to checking this out, and after that we can choose the LSTM, right? So that's span equal to 100, because these are basics of the stock prices. Let's adjust equal to, let's say, make it false. We don't need to take the adjustment, and after that we need to take in the mean of that. Okay, so this is nothing but my EMA1 exponential, the moving average of the data. So let's shift enter. Now we can copy this out. Okay, so you can also write it like that. You can write it like that. Let's say close like that. You can also do that. So it should be the 200, and it should be the 200. So 200 is nothing but coming from our percentage. Okay, df1. Let's see pct changes. You can see this is nothing but coming for the percentage changes of our data. Okay, you can change, you can actually checking any one of them. You can checking, and it is nothing but the percentage changes of the data. You can getting the value from here. You can make it here 300 or 200, whatever. Okay, so now what can do, we simply going to have the 200, right? So let's shift enter. Now let's try to plot it out. So copy this one, and I'm going to paste it here. Let's take some shell, and it should be the EMA 100 and EMA 200. This should be the exponential. So let's say EXP. Okay, EXP, exponential moving average. So let's see how the data look like. So mostly similar, just like the moving average, but having some different on that, having some different on that. Okay, yeah, just most like the similar. But for this technique, for the moving average technique, we can actually break the stock, because we can break the just stock for the one dress. So which one is not, which one can be true, which one not can be true. Okay, it can be false as well. But when you are going to the stock, you're going to predict the stock for the next 30 day or next 100 day, you can't do that. You can't do that. So for these cases, you need to choose in here the LSTM. You need to choose the LSTM over RNN. Why not RNN and why LSTM? LSTM means long short term memory. That means it can store the data in his memory cell, and higher RNN can't. Higher RNN can't. Yeah, RNN have, but it having some low memory issue, so it can be the overflow. So that's why in order to actually using the RNN, we need to using the LSTM. Okay, because in the LSTM you can actually save your data in the memory cell as well. Okay, so what I can do, we simply going to now divide our data for the training and the testing. Let's try to divide our data set for the training and the testing. So let's say pd dot data frame, and inside that I have to have my data from the closing value, based on the closing value, and then I am going to take it for 0 to, let's say, integers, length of my full df, length of my full data set, and after that what I can do, I can multiply with 70. That means 70% of the data is coming here in our data training part. So that's the data training part, and the rest of them is nothing but coming from my data testing part. So that's the data testing. So data frame close of integer, so it's not going from 0, integer of length of df of 70% and the rest of them. So it should be the integer of length of the df. Okay, so that's our training and the testing part is ready. So you can checking the shape of our training. So let's say shape. So this is how the shape look like. And if I checking for the testing shape, so let's say shape of the testing. So it's nothing but 1263. Okay, so checking the data testing shape of all that. Now what I can do, we need to actually pass in this data inside the min max scalar. Okay, because this is not it, this is a continuous value. We need to convert them into one range. So for that, what I can do, we're simply going to import min max scalar from the scalar dot pre-processing. I am going to importing here the min max scalar. So let's say min max scalar. Fine. Now I have to define here the scalar object. So let's say scalar equal to min max scalar, and inside that I have to giving here one feature range. Okay, feature range. So let's say feature range. For feature range is nothing but you can give any of them. So feature range, it can be to 0 to 1. You can also giving here the -1 to 1. You can do that. But I'm going to give it the feature range from the 0 to 1. That's when all the data should be transformed into the range of 0 to 1. Now shift enter and our scalar is ready. Now after that, what I can do is simply going to fit it out. Let's say scalar dot fit transform, and inside our data training, and that's our data training array. Cool. So that's our data training array. Cool. Now what I can do, we can check in the shape of this data training array. So let's say checking the shape of the data training array. That's our shape, and now it's converted into one array, because if I try to check in this one, you can see all the values should be transformed into the range of 0 to 1. Now we can divide them into x train and the y train. So let's say x train is an empty list and y train is also one empty list. So x is nothing but the dependent and the independent feature. That means x is nothing but your features and y is nothing but your target. Which one you're going to predict it out. Now what I can do, for I in range, we are going to taking the first 100, except the first 100, because the first 100, if we're checking here, the first 100 is nothing but the NaN value. So you don't need to calculate them. So what I can do, we simply going to remove the 100, and after the 100, we need to taking the rest of the value from our data training array. So that's a data training array, and we're taking the shape of that, and after that we're checking the 0. So if I'm using here this one, let's say copy this out, then you can see that what I'm talking about. So shape, you can see, okay, array is the defined. Okay, should be the data training. Okay, data training, copy. I'm going to pass it here. Shift enter. You can see just we got here the value. Okay, so we have the shape of that. Now when you have the shape, we can simply go and append it inside our extend and the y train. So let's append. We have our data training array, so we can pass it here, data training array, and we're going to removing here the first 100, and after that taking the rest of them. Okay, that's been first 100 should be the missing. That's been how you're going to starting the value, it should be starting from the 100. Okay, that's been the one is nothing but I is nothing but coming for the 100. Okay, so it is coming here 100, so 100 minus 100 is nothing but 0. This means from the starting from the 0, the rest of them should be go inside our strain data. Now for the y train, so for the y train, we can simply going to append here our rest of the array in our data set, and after that what I can do is simply going to convert them into the numpy array. So let's say data training array. So let's say data training array, and inside that I have to give me for I to 0. That's mean 100 to 0, the rest of them. And now I'm simply going to convert them into the numpy array. So let's say x train, and the y train is nothing but my np dot array. Inside that I can pass in here my x train, And after that, you can passing here np.array the white ray. Cool. So shift enter. Now our dataset is divided into the extend and the white ray. So if I try to checking this one, the shape of that, then you can see how the shape look like with having one step. Okay. Now it's time to building our model. It's time to building our model. So let's say model building. So okay, we are going to building here one sequential model. Okay, sequential model, that's means passing the data from one model to the another model. So let's importing here the important library. Let's say from keras dot layers, I am going to importing here the dance layer, and as well as I'm going to importing here the dropout so that it can deactivate some of the network, and as well as the LSTM, that's called the long short term memory. So let's say from keras dot models, I'm going to importing here the sequential. Okay, that's our model. I mean, we're simply going to load it out. Now, the input of the LSTM, when you're going to keep on input to your LSTM model, it should be in a 3D array. Okay, keras.layers. Okay, it should be layers. Okay, so when you're going to giving your an STM input, I mean, when you're going to give any input to your LSTM model, it should be one 3D array. It should be one 3D array. So 3D array is consisting your batch size, your the time steps, and as well as your sequence length. Okay, batch size is nothing how many batches of the file is coming here, and time step is nothing but the steps of the time. It can be t1, t2, t3, because LSTM is just working like based on the time. That's why LSTM is basically used for the time series forecasting types of data. So however the stock price is nothing but the data based on the date, right? Time series and the sequence length. So the output of the LSTM model could be an 2D array or the 3D array. It can be 2D or it can be the 3D, depending on the returning sequence. Okay, let's say if it is a 2D, if it is a 2D, if it is a 2D, then it should be the batch size. It should be the batch size and the units. If it is returning as a 3D, so it should be the batch size. It should the batch size. Oh, batch size. Oh, batch size and the time steps and the units. Okay, this is all about the LSTM. Now let's try to building our model. So what I can do, I can give it here to the markdown, and let's hit enter. Okay, and after that you can also making it code, I hope so. Okay, we can do that. Let's make it markdown. Okay, now let's try to building our model. That's a model equal to sequential model, and after that we simply going to adding here our model. So let's say model dot add, and inside that I need to giving my LSTM, and I need to giving my units. So our units, let's say first 50 units, and our activation function is nothing but the relu activation function. Let's say relu, and after that I need to giving here one return sequences. Okay, return sequences. Which one you're going to return here? Okay, which one you're going to return here? That's a sequence. Okay, sequences is equal to true. Bus. Okay, and it also giving the input shape for the first one. So let's see, input shape is nothing but my xstring dot shape, and the first one, and going for the one. Okay, this is nothing but the first shape of that, because we have some data, and after that we need to having our shape of that is nothing but the one. Now let's try to add the model. Let's add. Okay, let's add the dropout. Let's say 20% of the neuron should be deactivated for the first time. So, and for that, we could adding here our LSTM model. So we can copy this out and we can paste it here. And after that, we need to change this our unit. So it will be 16. And we have our input shape. It's not there because input shape should be in the first of your uh, input neurons. Okay, Now we can copy all of them. We can copy one by one, and you can paste it here one by one. So let's paste it here. So this is the second one. Third one, it should be the 80. It should be the 120 based on our paper actually. And then we can add in here model.add the dense layer, and inside that into giving here units should be 1, because this is nothing but my predicted value, and this is the last layer. Now to do some changes on that, this is dropout should be the 0.5, this is 0.4 and 0.3. Now that's mean after one layer to another layer, your dropout should be changes. It should be the 20% first, then after that it can be 30%, it can be the 40%, and it should be the 50% further. And then for the last one, we don't have any return sequences. We don't have any return sequences. Now shift enter, and our model is ready right now. So we can see the model summary of that. Okay. So that's our model summary. Okay. So now what I can do is simply going to using here our data and try to fit it out. So what I can do, let's say model dot compile, and inside that I can giving here my optimizer. So let's optimizer, let's say add up optimizer, and after that I can giving here my loss is nothing but the mean squared error. So that's mean squared, okay, squared squared error. Error, okay, should be the mean squared error, and after that I can fit it out. So model dot fit, and inside that you can giving here my x train data and nothing but my y train data, and after that I'm giving here the epochs. So let's epoch equal to 50 epochs. Okay, now it will starting the model training, so it will start it. Okay, yeah, it will taking time, so I get right after when the model training is completed. Okay. Okay, so now what I can do is simply going to do some testing on our previous data. That's been first 100 days of data. We are going to pass it to our model and try to predict our data with our original data set. Okay, so what I can do is simply going to using it from our data training. So let's say data training dot tail, and you're going to taking here the 100 of that. Okay, that's nothing but one data frame. If I go up, you can see here this is in the from of this data training array is nothing but one numpy array. That's mean we are taking here this data training without applying here the scalar. Okay, raw data. Okay, so now what I can do, we taking this data for the first last 100. So it's nothing but my first 100 days data. Okay, this is also on data frame. Now what I can do is simply going to append this data. So let's say past data to be appended to our data testing. Okay, and also giving here the ignore index equal to true. Okay, so last of the data or the first 100, why you actually adding it out? Because see, when we are going to testing it out, the first 100 value should be the null. The first 100 value should be null. So that's why we're taking the data from the training and we're simply going to making it as a non value, because the first 100 should be gone. So that's why in our testing data, we're going to adding here the first 100 days of the data, just like for the non value. Okay, because you'll do it out, because if I go up, you can see here we actually added taking here the first 100 data, because we applying here the moving average. So first 100 data is don't have any value. So that's why we're taking here first 100 is just from taking the data from the data set. So that's our final df. Okay, that's our final df, and as well as this is nothing but my testing df as well. So what I can do, I am simply going to pass it inside my scalar dot fit transform. Okay, transform, and inside that I can passing here my df. That's my final df. So final df. So that's nothing but my input data. So that's input data. Cool. So let's shift enter, shift enter. Okay, you can see first 100 days data is appended inside our testing data as well. And you also ignore our index for that. You can also checking your final df here. So let's say final df dot head. Okay, you can see the how data actually look like. You can see some values. First 100 value should be none, because you're going to applying here the moving average concept. Now let's try to testing it out. Okay, so what I can do is simply going to copy the same technique for the testing data. So you're going to copy this one, and first 100 should be the none value. So that's why we simply going to do some changes on that. So it should be the x test, and this should be the y test, and as well as in our data training array it should be our input data. This is nothing but my test data. Okay, and inside that you're giving here our input data, and here you're giving here our input data as well, and this is should be the x test, so it should be the x test, and this is should be the y test. Okay, because you're testing it our testing data. Okay, so it should be the x test, and this is should be the y test, and same thing following here, so it should be the x test, and this is should be the y test. Cool. Okay, any problem here? Let's check it out. So 100 input data is a shape, x test dot append, input data same thing, y test data same thing. Okay, just like that. So our testing data is ready right now. We can checking the shape of our data. So you can checking it here, the shape of that. So you can see this is how the shape look like. This is the moving average value. Okay, this is nothing but of the shape of the data and how many rows are available on that. Now let's try to predict it using model.predict, and inside that we can pass in here my x test data, and this is nothing but my predicted data. So let's say y predicted. Okay, so till doing the predictions you can see 40. Okay, now what I can do is simply going to checking the shape of the y predicted. So y predicted dot shape, and you can see here this is the shape of our y predicted. Now what I can do, we need to have the scalar as well, because you need to counting it in the from the scalar format. So that's scalar dot scale. Okay, so that's our scale value 0.0035166. So as of now all the data is scaled, so you have to unscale them to understand it properly, because you see we actually feed transform the data. Now if you're trying to plot it out, you need to also unscale the data. So we have some scalar value, right? So what I can do is simply going to uh, save it inside the scalar factor, and our scalar factor is nothing but 0 point, okay, 0 0.00, okay, that's our scalar factor 0 35166. So yes, you need to divide it by 1. Okay, 1 divided by 0.35166. So let's say y predicted equal to y predicted, okay, okay, into scale factor. Okay, and do the same thing for the y test as well. So let's say y test into scale factor. Okay, that's it. Okay, so scale factor is not defined. Scalar factor, it should be a scalar factor. Okay, that's it. So our scale factor, I mean our predicted value is actually ready right now. So now what I can do, we simply going to print it out. Okay, so what I can do is simply going to copy this one, and after that we can paste it here just to white, and that's our figure, and inside that we can giving here our testing value. So let's say y test, and label we can give it here. Let's say label is nothing but our original, okay, original price, and here we have our predicted price. So we can removing this one, and you to giving here the y predicted. Okay, and in our labels we need to giving here the predicted. Okay, let's say predicted price. Okay, that's it. Fine. Now shift enter. Now you can see here how the data look like based on the original data and the predicted data. Okay, you can see here how it did look like. Okay, in some of the cases you can see it having some gap. Okay, if I giving here one another scale factor, so let's try to giving here another scale factor. Let's say 0.00729 727. Okay, now you can see here how the scale factor look like. Okay, you can see the how a scale factor look like. Okay, So you can any of them, you can give a actual analysis on the scale factor. Okay, I just gave it actually here the scale factor, this one. Okay, scale factor. Okay, now you can see here how the graph is look like. Okay, not so bad, not so bad. Okay, so now what I can do, we're simply going to save our model. So let's say model dot save, and inside that you can give in here, let's say stock dl model dot is5, and our model is saved. Okay, so if I see that, you can see here we have the stock dl model dot is5 file. Now using these ones, we're simply going to creating here one web applications. Okay, so you can giving the line height as well. So you can, let's see a line, you can giving here the line width. Okay, like that. So let's copy this out, just to white. We have this one, so you can using the line weight equal to 1 so that you can see it clearly as well. So here you go, and we'll be giving here the line weight here. Okay, now you can see how it will look like. Okay, from here you can see stock, how the stock is still going up here. Okay, it is following the same thing. Okay, yesterday. Okay, so this is the original prices and this is predicted prices. Now what I can do is simply going to creating here one web applications. Okay, so let's try to do that. Well, so now it's time to creating here our stock trend prediction applications using Flask framework. And this is the code for that, and I'll write it down in our BS code in app.py file. And also inside this section, you can see here one folder called templates. And inside this templates folder, I give here one HTML file. I just write it down in the form of HTML, which one is containing the bootstrap and the CSS as well. And also inside this section, you can see here a folder called static. Here you're going to saving all of our graph as well as our data sets. So now what I can do first, I am going to run in this app.py file, and after that I'll show you that, I will teach you that how the UI is built and how the UI is look like, and how can you break through all of the UI component and try to building these applications. And also you can see here how I run in this application. Yes, it's taking time because it is loading this deep learning model from our folder. So that's why it's taking few times for loading it out. And you can see that our server is running in this local host port. You can see loading. Okay, so now what I can do is simply go on here and try to checking that how many time it will take it out. Yeah, it is taking just like 30 seconds for loading it out. Yeah, now you can see it's loading and give me the response. So this is our UI, it having just one heading, and inside that you can see just having one input box and one simple submit button. So here you can actually giving here your stock ticker. Okay, so here you can actually get your stock ticker if you go on the Yahoo Finance website, and let's say I'm going to searching here for the Apple, and Apple is the equity name is going to is APL. So you need to giving the sticker name inside your entry box or your input box. So I'm working on the Power Grid. So let's say Power Grid. Okay, Power Grid. So you can see Power Grid Corporations of India Limited. So equity name is powergrid.ns. Okay, so you can give it here. If I click on submit, okay, let's try to give it here another name. Let's call Apple, and click on submit. So what it can do, it will try to loading the data from the Yahoo Finance website and try to do the EMA, I mean called exponential moving average, and the moving average, as well as it will show the original value as well as the predicted value in your applications. Okay, so it will taking time. You can see here taking time. Yeah, not too much. So you can see how it will look like, and you can see here the prescriptive data from January 2000 to the November 2024. It can be the October because it will, the data is nothing but from the October that you see on that. It can also change the line height of all of the things. Okay, so now what I can do is simply going to I am simply going to make you understand that how it will actually create it. Okay, so let's go on the index.html file first, and don't worry about the code. You can get all of the code in the descriptions as a GitHub link. Okay, so you can see here just getting here one link of that, and also give them title, and this is the style for that. And after that, we're simply going to creating here on container, which one having on a stock trend predictions, which are nothing but this one, and also having on labels, which one is nothing but called a star, enter here the stock ticker in the labels, and we have one input box, which one taking the input from the users. And you also giving the ID is called the stock, and name is nothing but the stock. So based on the stock, we will taking the data from our, we're going to pass in the data from the index.html file to our app.py file. Okay. And after that, we have on the submit button. We're just having a submit button. So this is nothing but the UI. This is nothing but the UI. So when the data is going to our app.py file, it will give me some response, and my response should be showing up in our UI. Okay, so this is the code for that. So now what is the float path EMA? What is the EMA? What is the moving average? So it's coming from our app.py file. So let's go on here, app.py file. Okay, so first you import in the numpy, then input the pandas, and also input in the matplotlib and also the load model, because we have our pretend model that I already trained it out. It's called a stock price prediction.ipm file. You can also see this out. Okay, then you also importing here the random template and also the Flask, because you're going to creating here the Flask application. That's why you're also importing the Flask. And random template is nothing but random the template from our index.html folder, and also requested because into taking the data from our index.html file based on our name, right? And after that, you need to using here the send file, so that we can actually save this file inside our static folder, and you also download the data set from that. If I go on that, you can see here, you can see appear is Apple, and if I click on this data set, download data set, I can simply go into download the data set from here, Apple. Cool, right? Cool. Is it cool? Yeah. And you're also importing the min max scalar, because if you go on before, we actually apply here the min max scalar in our data set. Okay. And also import the OS is not needed at all. Okay. And you also import the date time because it's needed, and also Y finance because you need to load the data set from our Yahoo Finance website. Now we're simply going to creating here an applications, and for the demonstration purpose, I mean, I actually if I actually give some comment. Okay, if you can also ignore that. Okay, so load the model, make sure your model is in correct path. If you see the code in the GitHub, you can also read in this comment line, and you can it's made to be understandable, no problem. Okay, and after that, you're simply going to creating here a route of that simple route. Okay, is the initial route, and we give it a method is called the get method and the post method. Okay, and if the df of index is nothing but, if the method is nothing but the post method, if the method is nothing but the post method, we simply taking the data from the users using this stock name. Is the stock name. If I open this out, inside the stock name, using the stock name, we simply going to get in the data from the users. And if it is not in the stock, if it is not already not in the stock, so we're simply going to take in the default one. That's called powergrid.ns. And after that, we're going to defining the start date and the end date. And after that, we're simply going to download the data set from our Yahoo Finance. Okay. And after that, we're simply going to describe it. And we're simply going to calculate the exponentials moving average for the 20, 50, 100, and the 200. And after that, we do the data splitting because you will do it out. Okay. Then we're simply going to scale our data. Same things, we do it out in our stock price predictions. And after that, we're simply going to prepare the data for the predictions. Same thing for the first 100 days that actually do it here. Okay, if I go down, or otherwise you can go on the this one, and you can see here we actually do it out for the first 100 days, just like that. If I see that, you can see first 100 days. Same thing. Okay, same thing. Okay, and after that, you're simply going to do the testing one, then make the predictions, and you also do the scaling, and also going to plotting all of them. Closing prices versus time chart, same thing. You can see EMA 220, EMA 50, EMA 100, EMA 200. Okay, I just printing here the moving average for the exponential time. You can also do it for the moving average for the each of the graph they're actually showing off in our stock price prediction IPM file. You can actually add it down. You can simply add it down. So plot 3, plot 4, and after that, is simply going to save our data set inside a folder. And then we're simply going to passing all of the data inside the parameter of the random template. So you can see here plot path EMA 20, 50, EMA 100 or 200, it will showing up on here. That's been how we're simply going to pass in the data from our Flask applications to our index.html file. Cool. And after that, if it's not, we're simply going to run it out. And if the random is nothing but route is nothing but the download file, then we're simply going to download the file using this send file. And after that, we're simply going to add the attachment should be true, and it will download the applications, download the dataset in your folder. Simple. So you can see we actually giving here all of the data as a parameters. Okay, data descriptions and the data link as well as the our chart. Now let's go on the index.html. Now you can see if the plot of the path EMA is this one, which is coming from here, and you need to showing it out. You need to showing it out in a div classes, which one is nothing but a heading, and we're simply going to show the image sources. Okay, it's coming from the static folder, because inside of a static folder, when you're running these applications, when you give the input from you're taking the input from the users, it will automatically store inside our static folder. Okay, you can see you have the graph of that. So from this it will try to taking all of the data, and it will showing up like this way. Okay, you can see for the 100 to 200, for the float path predictions, for the data descriptions, for the data settling. Simple, just simple. Okay, now you can also decrease the line height of that. You can just giving him a line height. So let's say time chart for the predictor original, and you can give it here on line height as well. So that's a line width, not line height, actually line width. Okay, line width you can give it here, let's say 1. Okay, is it working? Yeah, is it working? It's working. You can copy this out, and we can give it here this one. Okay, simple. Now let's try to save it out, and let's try to run in this from here. Okay, simple. And I'll show you that the simulations that you can see, just like the MacBook Air, the iPhone, just like the responsive things. Okay, don't worry, I'll show you. Okay, so yeah, it's loading right now. Yeah, it's loading. So what I can do is simply going to go on here and hit enter, and now you can see here that's our application, and click on submit. But before that, let's open our extension. It's called mobile simulator, and our extension is ready right now. Let's go on the full screen mode so that it's look good. And now that's our mobile phone. Okay, and now let's click on submit, and now you can see here this our link. Okay, this is called the fake element. Okay, and it will try to generating here stock prices. Okay, submit is clicked or not? Yeah, submit is clicked. Okay, so let's go on the BS code and try to check that it is working. Yeah, you can see here it will try to generating all of the things and try to do the predictions. You can see here predictions, right? So anything wrong? So user is likely to be mad. Okay, you can see here. Yeah, you can see how the trend look like. Yeah, how the look like is it? And if I go on there, that's a Samsung. Okay, it's a Samsung devices. And let's go on the 12 Pro Max. Yeah, it's in the 12 Pro Max. Because it is actually loading that. You can't use the Pro version. That's why it's give me this kind of problems. And let's using the MacBook Air. And let's click on submit. Okay, submit में click हुआ है क्या? Yeah, submit. Okay, so you can see here how cool is it. Okay, let's see. थोड़ा टाइम लगेगा क्या पर, क्योंकि प्रेडिक्शन ले रहा है ना. देखो प्रेडिक्शन ले रहा है. Okay, cool. Okay, बस. You can see here this one, this one, this one. Okay, and also you can see here. How cool is it? Yeah. So this is how you can actually creating the application using Flux, and you can also do the simulations. So that's it for today now. Hope you enjoyed this tutorial, and make sure subscribe our channels and hit the bell icon and comment so many, because it give me uh क्या बताऊँ आपको, it's give me energy to making some new projects and cool projects as well. Okay, so thank you and bye bye, and I'll be back with the tutorial. So till then, take care.